Hello everyone, we have here a problem about calculating the enthalpy change. Okay, so first of all, if you have a problem asking you to calculate the enthalpy change, you should check if it is combustion, neutralization, solution, but luckily it's already telling you that it is neutralization. And you can also know if it's neutralization or any other type of reactions from the equation itself. It's already telling you that you have a volume here, centimeter cube. You have a concentration of hydrochloric acid is mixed with another volume and the concentration of sodium hydroxide. So it's mixing sodium hydrochloric acid with sodium hydroxide. So it is neutralization. Okay, how I may answer similar problem? First of all, I do have to return back to the formula that I should use, which is delta H. Delta H is equal to minus Q over N. Why it's minus here? Because it is neutralization. It is neutralization, so it's an exothermic reaction. For combustion reaction, neutralization reaction, it is negative. It should be negative by default because it is an exothermic reaction. Okay, but for solution, it depends. It depends on the reaction. Maybe sometimes it's exothermic or endothermic. Okay, so let's complete our answer here. So it should be negative mc delta t over n. Okay, so it should be mc delta t over n. For the neutralization, n is the both volumes of the acid and the base. You should just add them. You should just add them. So they are 300. So they are 300. We have here 300. So it's negative. The mass is 300. 300 is coming from adding the volume of base with the volume of acid multiplied by C, which is the specific heat capacity for water, so it's 4.18, multiplied by the change in temperature, which is 1.36. Okay, this is all over N. What's N here for? For the neutralization reaction. N is for the amount of moles of water produced. So we should write the equation. We should write the equation HCl for this reaction plus NaOH is giving NaCl plus H2O. How I wrote this formula is acid with base giving salt and water. We can observe that the mole ratio is 1. The mole ratio is 1 to 1. 1 to 1. So you can use the mole ratio here is 1 to 1. So the number of moles of HCl will be equal to the number of moles of H2O. Or the number of moles of NaOH will be equal to the number of moles of H2O produced. If we have the limiting reactant, but I think we have here exactly the same number of moles that could produce the same number of the same number of moles of water. Okay. So let's calculate the number of moles of HCl we have here. We have here a number of moles. We should return back a little bit. The N is equal to CV. N is equal to CV. So N here, the number of moles for HCl is C, which is 0.15. Is that? And V here is V, but V here is 200 centimeter cube. And the concentration is coming in liter. So I should divide the 200 by 1,000. So multiply by 200 over 1,000 or multiply by 10 to the power negative 3 is the same. Okay, so the number of moles will equal to, so they will equal to 0.03 mole. Okay, so the number of moles of water produced will be 0.03 mole. Okay, if you would like to double check if the number of moles of NaOH, this will be appreciated. To check if there is a limiting reactant or something, we have here the concentration of NaOH is 0.3 multiplied by, again, it's coming in centimeter cube. You should convert it to liters, so you should have 100 over 1,000. It will equal to 0.03 moles. So in this problem, they are bringing exactly the same amount of moles of both acid and base. So you can use any of them. Let's return to our formula for the delta H is equal to minus Q over N is equal to minus MC delta T over N, which is equal to minus 300 again is coming from the volumes of both acids and bases, 4.18 specific heat capacity for water, 1.36 is the delta T. What about N is for the water we just calculate, so it's 0.03. So this will equal to minus 56.8 kilojoule per mole. Kilojoule per mole. Okay, kilojoule per mole. Okay, so let's move to the next part of the problem. Predict the temperature rise if the experiment in part A is repeated using 400 centimeter cube. 400 centimeter cube, so it's volume. And you have here concentration of hydrochloric acid, another volume, and the concentration of sodium hydroxide. What do you think? You can just compare between the data you have here. You can just compare between the data you have here with the data you have in A. You will observe that the volume is already duplicated. We were having 200 centimeter cube, and we have here 400. We were having 100 centimeter cube NaOH, and here we have 200, so the volume is duplicated while the concentration is the same. Okay, so let's check the relation. It's telling us to predict the temperature rise. What we have here in the formula, we have delta H equal to minus MC delta T over N. If the volume will change, it will affect the number of moles. If the volume changed, it will affect the number of moles. And it will affect M. So it will affect both M and N. Because M is simply 400 plus 200. Okay? And if we would like to calculate the number of moles N, we are also calculating it from the V multiplied by C. So I can tell you without even calculating it, doubling the mass and doubling the number of moles, the change in mass and change in moles will be cancelled out. Then we will have the same temperature change. We will have the same temperature rise, which is 1.36 degrees Celsius. Okay, why again? Because again, the volume here, or M here, is coming from adding both volumes, 400 with the 200, 400 with the 200, while the N number of moles for water is coming from the hydrochloric acid, with the number of moles of hydrochloric acid. We can calculate it. If you would like to try it, I can show you how can we do that in the next one. In the next one, we have here in the next one 200 centimeter cube of, so we have here volume, and we have here concentration. We have here volume, concentration. So again, we should predict the change in the temperature. It's very, very easy again. Why? Why it's easy? Because we have the formula, which is delta H is equal to minus MC delta T over N, all over N. What happened here is we have 200 centimeter cube, 200 centimeter, 100 centimeter cube, 100 centimeter cube. So we have the same mass, So the mass is the same as part A. The mass, the mass here is the mass here in this problem. M is 300. Okay, grams, of course, grams. Okay, what about N? What about N? N here is different because we have different concentration. The concentration is doubled than A. The concentration here is doubled. Okay, it was 0.3, and here for the NaOH is 0.6. The constant, so mass, the mass is doubled, the mass is, the same, while N is doubled here. Because we can calculate N for hydrochloric acid, which is 0.3 multiplied by 200 over 1,000, and with simple calculation we can do it. We will find that the number of moles will equal to 0.06 moles. So again, we are comparing between the number of the mass in here is equal to the mass in A. The mass in A, which is 300, which was 300. But the number of moles is doubled. It was 0.03, it's here 0.06. What do you think will happen to the temperature when the number of moles is doubled? When the number of moles is doubled, so it should be delta H here. Okay, what will happen to the delta H? It should be doubled. The temperature rise will be doubled to cancel this change. So if N will be doubled, delta T will be doubled. So it's simply 1.36 multiplied by 2. So it will be 2.72 degree Celsius. This is the change in temperature. Okay, very good.